this is Maya. Let's get into it. You dumped all your company docs into a vector database, and now your AI agent is quoting 2022 pricing to your enterprise clients. If you are an engineering lead, AI architect, or CTO building RAG pipelines in production, this is the most common and expensive architectural trap in enterprise software today. We call it dumb RAG, or context flooding. And it happens because developers treat a 1 million token context window like a secondary hard drive instead of high-speed system RAM. When foundational model providers expanded context windows from 4,000 tokens to 128,000, and eventually up to 1 million tokens, engineering teams made a fatal assumption. They thought, why bother chunking, filtering, or compressing our documents? Why spend time building complex retrieval logic when we can just pull the top 20 or 50 vector chunks and dump entire PDF manuals directly into the prompt? That assumption completely misunderstands how transformer self-attention actually works. Let's look at the underlying math inside a neural network when you flood the context window. In a transformer model, the attention mechanism calculates how much weight every single token gives to every other token using queries, keys, and values passed through a softmax function. A softmax function normalizes raw numerical scores into a probability distribution that sums to 1.0. When your context window contains only 3 hyper-focused paragraphs, the softmax distribution is sharp. The model assigns 80 or 90% of its attention weight directly to the active policy rule it needs. But when you flood the prompt with 50 uncurated document chunks containing raw HTML boilerplate, legal disclaimers, 2022 pricing tables, and 2024 policy updates alongside your 2026 master file, the sequence length explodes. As token counts grow, the softmax denominator expands, and attention weights get diluted across a noisy key space. Instead of a sharp 90% focus on the correct rule, the attention probability flattens across dozens of competing paragraphs. In operating system architecture, we call this RAM thrashing. RAM thrashing happens when virtual memory gets so overwhelmed by page faults that the CPU spends more time swapping pages back and forth from disk than executing actual code. The exact same thing happens inside an LLM context window. When an agent processes 20 document chunks where 19 contain obsolete rules using the exact same vocabulary as the active rule, self-attention thrashes. It suffers from needle-in-a-haystack drop-off, misses active constraints, pulls details from outdated files, and outputs authoritative hallucinations. And raw vector similarity search makes this worse. Most vector databases use bi-encoder models to measure the cosine angle between query vectors and document vectors. But cosine similarity measures vocabulary direction, not temporal truth. A PDF from 2022 discussing enterprise pricing and a PDF from 2026 discussing enterprise pricing occupy nearly the exact same position in vector space. Raw semantic search returns both with high similarity scores, dumping active rules and historical artifacts side by side into your prompt. How do we fix this architecture in production? You build a multi-stage context precision gateway. Step 1. Treat prompt context like high-speed RAM. Never use prompt space as an unindexed dumping ground. Every token injected must carry verified, high-density informational weight. Step 2. Enforce temporal metadata pre-filtering at the database layer. Index all document chunks with strict schema attributes: effective date, document version, tenant ID, and status. Before scoring vector distance, hard exclude any document marked deprecated or dated prior to your active cutoff. Step 3. Deploy cross-encoder re-rankers. Bi-encoders process queries and documents separately. A cross-encoder model, like BGE ReRanker, evaluates query and candidate chunks together through full joint self-attention. Pull 15 candidate chunks from your vector store, pass them through a cross-encoder, and truncate to the top 2 or 3 chunks. This strips out 80% of semantic noise. Step 4. Compress raw text into structured JSON. Run an offline ingestion pipeline that converts documentation into structured key-value JSON summaries to maximize information density. Shifting from context flooding to precision retrieval collapses API token costs by 70%, cuts latency, and drops hallucination rates to near zero. Stop dumping your hard drive into RAM. Shift your retrieval metrics from context volume to context precision. If you're building multi-agent control towers, see how we build digital labor at letsaskclaire.com. Thanks for listening. See you next time.